Hello guys, so welcome back. So very good morning. Today we are going to see the Leetcode question in which we will see add binary. Okay, so the question 67 we have here is to do addition of two binaries, right? And then we will represent this one. Okay, so two binaries we have given A and B, and we have to return sum as a binary string. Okay, so let's suppose the first example we have given is A equal to in double quote we have 1 1 and B we have given 1, right? You can see that. So once we will do A plus B, right, we will have to return 100, let's suppose. Sorry, okay, 100 we have to return 100, okay, in this binary string. So what is the mean of this one? Okay, so actually these are binary, right? Binary A and binary B. One is binary and one is also binary, right? So if you'll represent these binaries, right, if you'll represent these binaries and say that what is the you can say if you'll convert these binaries into, you can say we have the Java function, right? Integer dot, if you'll do the parse, right? So it will convert this let's suppose binary. I'll pass 1 1 and then I'll pass 2, right? Like this. Let's suppose. So what it will give, it will give you integer of this number, you can say integer of this binary, right? So actually if you convert this A into integers, right, so what you will do, you will do integer dot parse, and what we'll see, this value will give what 3, right? Why it will give 3? See, actually when we are when we are doing what give me 1 minute. Yeah, when we will do what integer dot parse, so it will convert this binary. We are saying that this is binary number, okay, and we have to convert this one into integer. So this binary will get converted and it will represent as a 3, right? Similarly if you convert B, right, this one, similarly it will give what 1, right? Why? Because we know as you remember, there is our formula 3 2 4 3 2 1, like that we have the formula, right? So if we'll do 1 1, right, so we will read these two, right? So 2 plus 1 is what we are getting 3 in the binary representation, right? As you remember the formula we used to do in the college, right? 3 in the binary to integer. So then we will get what 2, we'll consider this 2 as a 1 and this is as 1. 2 plus 1 is 3. Now we have only 1. So if for the B, right, so for the only one this is the 1, right, and what we will get 1. So if we'll do this plus, right, what we will get, we will get 3 and 1, right? So while doing this one, what you can do, once you will convert this 2 into integer, right, then what you can do, you can do A plus B. Okay, you know that what is A and what is B, right? And if you convert this one, so it will give what if you have already converted, right, if it will give you some you can say binary, right? Whatever the data we have A and in B, right, like that. So what you will do, you should convert this integer dot parse, right, and A for A and B, and do plus, and you can return this value, right? Let's suppose what I mean to say, let's go to the browser and then we will implement this one. Convert the A and B, right? So let's suppose what I'm trying to do here. Let's suppose we will take one, I will convert A into integer, you can say. How will I do that? Let's suppose we have integer s1, suppose for A. What I will do, I will take integer, right, I will take integer dot method parse int, right, and I will pass what we have A we have, and I will pass binary, we will pass 2. Similarly I will pass int s2, and then I will say integer dot pass, and I will pass B comma 2. So now these two value has been converted into integer, right? If you'll print here, if a is 2 and a is 1 and b is what 1, right? So what we will see, you will get here 3 and here you will get what 1. If a equal to what 1 and if b equal to only 1, right, then you will get this one. Okay, so what I have to do, we have to do sum, right? So to do the sum, we should do return there is a if you want to convert from integer to binary string, right, there is a function in integer. You can try integer dot to binary something. Yes, binary string we have, right, this one. So we will pass what s1, we'll do s1, and then what you can do plus s2 like this. So let me try compile this one, working fine, you can see. And then let me submit this one. What I'm getting error here. I think I have to remove and let me remove from here. These are I think what happened, number input string is this. Okay, time error is coming. Okay, so what we can do here, we can, let me try to put directly here. Is it working fine or not? Actually he has put a big int and it will not store the, you can say here in the value, right? So now we will directly convert. Let's see, we are not holding now. Yeah, so actually what is happening, we are getting a big number, right? You see, we are getting big number, right? So getting the big number, it will not work for you. Like to getting the big number, it will not work for you, because if you pass the big number, right, so it will not get stored there onto the integer, it will overflow, right? But if you understand this one, right, let me go to the browser, sorry, here. So this approach, actually this approach will take overall you can say because this is if you will take the big integer, it will not work, right? So what does it mean? So overall algorithm, it will take O n plus m, right? Because the time complexity TC is taking what O n plus m, because see, we have two drawback which could be used against you can say during your interview, right? The first, in Java, this approach is limited by the length of the input string a and b, and once the string is long enough, right, the result of the, you can say, conversion into integers will not fit into integer, okay, or long or big integer, you can say. So let's suppose, what I'm trying to say, let's suppose we have 33 1 bits, okay, right, 33 1 bits we have, and b doesn't fit, right, doesn't fit into integer, okay. So if we have 33 1 bits and b doesn't fit into integer, right, no fitting, okay. So what will happen, if you'll take another, let's suppose 65 bits you will take 1 bits and b doesn't fits again for long, right? So 33 bits is enough for the integer, 65 bits is enough for, you can say for long, right? This is, I'm telling about integer, and this I'm telling about long, right? Similarly, there is a big integer, right, and it's about as you remember, there is 5000000, I think something like that we have, and then for the 1 bits, right, and then here b again will not fit for the big integer, right? Big int. Okay, so there is you can say limitation is there, right? So either you will use this one, right? So there is two things, first n and m, right? So if we are taking the first in let's suppose in 33-bit integer, 65-bit and then we are taking into long, right? So it will not work for you. Okay, so what I'm trying to do say, to fix this issue, what we should do, we should use standard bit by bit computation approach, right? That we will talk about here, which is suitable for what? Long input string, right? So this method has a quite low performance in this case of the input, large input numbers, you can say. And once we will use this manipulation approach to speed up the solution, what we will do, we'll try to use the approach that is known as what we'll say bit by bit computation. Okay, so this is a very good approach actually, you can say. So why? Because see, if you will consider any classical algorithm, right, so that's good, right? There is no conversion from the binary string to decimal. And back here, let's consider the number bit by bit starting from the lowest one, and compute the carry this bit will add, right? You know that, right? How to do carry? We will add one bit and one bit, right? So let's suppose I'll say there is one bit, right? So we will do 1 1, it will become 0, right? And I think yeah, I think 1, right? I think 0. Let's suppose 0. And if we have already one bit, we will say 0, right? Yeah, I remember. And then this will, one carry will be there, right? One carry will there, we will add here, right? One carry is got here, one carry will get here. So what we will do here, we'll say 1. Like this we will add, right? So if this is our A and this is our B, so we will do the computation like this, and it will become 1 0 0 like this in the binary computation, right? So start from the carry. What we used to say, carry is 0, right? So when we are doing the first time, this one and this one, right, 1 1 came, so carry has got incremented, right? So if number 1 has 1 bit in the lowest bit, let's suppose we are talking about this one, right? So and we have to add 1 to the carry, right? So then we have to do carry is 1, right? So in the lowest bit, if the number has number A has 1 bit in this lowest bit, right, then what we will do, we will add 1 to the carry. And the number and the same for the number B. If B has 1 bit in the lowest bit, then what we will do, we will add 1 to the carry, right? So at this point, what will happen, the carry for the lowest bit could be equal to you can say like that. What I'm trying to say, you can represent this one like that. We have this one, right? And we have 0 1 2 like this, right? Or you can say 1 0 like this too. Okay, so the thing is, right, the thing is at this point, carry for the lowest bit could be equal to what, this to equal to this, or you can say this, right? Now append the lowest bit, right? What we will do now, append the lowest bit of the carry to the answer and move the highest bit of the carry to the next bit order, and repeat the step again and again till all the bits in A and B are used up. So if there is still non zero carry to add, reverse the answer string and do the job done, you can say. So what I'm trying to say, let's suppose we have one example. Okay, let's suppose here what I'm trying to say, let's suppose we have A and it contains what, 1 1 1 1. Okay, these things we have. Okay, we have A 1 1 1. Now let's suppose we have B and B contain 1 0. Let me make the array. So we have to this value, right, and rest of this is blank. Let's suppose only two value is there, no, that nothing is there. A is 1 1 1 and B is what we have 1 0 something. Okay, let me erase this one. Okay, like this we have like this. Okay, now what we will do, if A is this one and B is this one, right? So now we will say carry is what? Carry is now we have 0 0 0 1. This is our carry, right? Because if we'll say 1 0, right, let's suppose 1 0, what is the carry we have? 1 initially, right? So what we will take, we'll take one answer also. Okay, we have answer. So initially we'll take answer like this. This is completely blank and 4 field we'll have here, right? Next time what we will do, if we'll let me give here, let me change the color. Okay, what I'm trying to say here, we have 1, right? So this one, and if we'll say if there is 1 bit in a, right, let's consider if there is 1 bit, in a, and that we have, see what we have a. Then what we will do, we'll add 1 to carry. So let's do, we will add 1 to the carry from here to here, correct? So what we have A have 0, right, and here what we have B we have 0. So we are not considering right now here, but we considering if A have 1, then we will carry into 1 as a 1. Okay, now carry is what? Now carry have, you can say carry have 0 1 2 like this. Append 1 to the answer, right? If we told you, right, if carry is 0 1, right, 0 1 binary, right, then what we will do, we will append 1 to the answer, right? Then we can say append 1 to answer and nothing to move to the next bit, and we will not do anything to the next bit. Then what will happen? Then we will see what we have carry. Oh my god, we have the carry. Then we will add here 1. Next time what will happen, 1 bit again we will get, right? 1 bit, there is 1 bit in A, right? We are here, so in A, and then what we will see, there is 1 bit in B, right? Then what we'll do, we'll do 1 plus 1, right? We'll do 1 plus 1, and carry will happen what? Now this is not 0 1, right? It will become you can say 0 0, right? And this is what we have. We will have you can say carry has now 0 0 like this, because we are adding A 1 plus 1, right? If we'll both have 1 plus 1 in A and B, right, here A and B have 1 1, then what we will do, now it will become what? 1 0, carry is 1 0, not now, this is we have 1 0. So now what we will do, if we have 1 0, right, 1 0, right, then what we will do, we will add 0 to the answer. So we will say 0 to the answer. Okay, and then move 1 to the next bit, right? When we will move to the next bit, we'll say 1 bit in A. We have seen 1 bit in A. Okay, so what we will do, we will add 1 to the carry. Now carry is what? Not 0 0, not 1 0, but it have what? 0 1, right? So when we have 0 1, then what we will do, we will say carry has 1 0, right? So then what we will do, we will append 0 to the answer. So let's do it, right? We have added 0. Okay, and sorry, we have not updated this one. So this is what we have now. 1 we have, so this is 1 we have, this is 0 we have, and previously it was 1 we have, right? Now you think we have to move next bit, right? So next we will see what? We will see 1. when we will see 1 means we have only one bit in A, right? So what we will say, we will update our carry, right? Carry is now what we have only one, so it means this case we have 0 1, right? Then what we will do, if the carry has 1 0, right, or 0 1, so in this case what we have, carry is 1 0, we have to append answer as a 0 here, correct? Sorry, we will update the first carry and then we will add 0 here, right? So in this way what will happen, let me clear everything so we will understand. I am trying to say we have A and B, right, each time. So what we will do, we will append, we'll check A and B value. Let me remove, this one. Almost I have removed everything. Leave it, let me write again. Okay, so what I'm trying to say, see what we have here, we have A have 1 1 1 and 1, we have what 1 0, and then the final carry will be what, we have 1 0 0 0 1, let's suppose, and the final answer will become what, because that we have already appended, so it will become 1 0 0, there is 1 0, right, and there is 1, like this it will become, our answer will become like this, because carry has what, carry has 0 1, right? Carry will got what, 0 1, you can say, if you make the base 2 binary. So what we have to do, we have to append 1 into what, into the answer, and that's why finally we got new here, because carry we are getting what, 1. Okay, so in this way what we will do, we will say this is our answer, this is our answer, we will have to return this one. Now if we'll talk about the implementation, right, this one, so how we will do that. So let's go to the browser and we'll try to implement this one. Okay, yeah, so first of all what we should do, we have A and we have B we have given, right? So let me first we will say, if we'll take we can say we should take what, let me say, we should start with what, we have A given and B have given, right? So we have to do in the carry way, right? Let's find the size first, right? So let's suppose we have n1, the length of A, right? So I'll take A dot length. Okay, A dot length, so we'll find the length. Another will find n2 and we'll say B dot length. First of all we should find the length. Why I'm doing this, first we see, if we'll check if n1 is less than what, n2, then what we will do, we will return what, we'll take one function add binary, that function we have already taken, right? We'll call this function and we'll say pass the value, we will make B comma A. Okay, we will reverse, and then we'll take we can say, if that is not the case, then we should find the, you can say, len length, and we'll say math function will take. Okay, math dot max, and we'll find which one is big, n1 or n2, which we will get our length, you can say this is max length. Okay, this is max length. So now what we will do, we'll make a one string builder, I'll let you know, wait, new string builder, that is SB, right? Used to say SB. We have created one SB string builder. Then we will take one variable, another is we can say our carry will start from what, 0. Next what we will take, we'll take one variable, that is we can say j is nothing but our n2 minus 1, n2 minus 1 we will do. Max size we will go like this, and then we will make a for loop, and then we will start from max length. Max length is what we have just calculated, max length we will start from max length, and then we will we should from not last we should take from the last, otherwise it will give you exception. Okay, so we will start from the last length, and it should not be I should not be greater than I should not get greater than -1. Okay, it's less than, not less than, -1. So we'll say I should be maximum, it will 0. Okay, and then we'll reduce I. This part is done. So we will traverse from maximum length from A and B, which one is big, from that one we will go. What we are trying to do, see, we have A and B, right? So A is, in this case, in the first example that we have taken, A we have 1 1 and B have 1. So we will start from, we will go to A to B, right? We will not go only for B length. So we will find big one, right? That's why we are taking. Okay, now I think you understood, right? And then what we will do, this things is done. Now we'll check the characters, right? We'll check, how we'll check the character. If we have we'll check on the a dot caret is a function, right? So if we'll find caret, some value will be there, right? I, let's suppose we have, this is at I, caret I, if equal to, let's suppose what we have, 1 we have. Okay, 1 character we have. Then what we will do, suddenly we will increase our carry. So now carry is incremented, right, as we have already seen. Okay, so better we will should plus, right? Better we should say plus character. Okay, now this is done, right? Once this is done, we will check another condition. Either we will check if the character at this one is this, then we will increment. If not, then we will continue. What we will continue, we should check the j is starting from n minus 2, n2 minus 1. Okay, so what we will do, we'll say j should also greater than -1. First we will check this condition, then we'll check its character. So v dot caret, this is also I, right? We should take care. No, now we should start with not A, we should start with j, right? And then we will reduce this one similarly. Okay, so j will do minus, and then what is the at we have j, so the last position we will come to the first till that. Okay, and if we will find this is also, we have what character as 1. Okay, so we will increment carry, again this is plus carry. Okay, now what we should do, we should check if we have carry, right? In the carry we should check carry, if carry is we'll take modulus, suppose mod, if equal to coming 1, right? Suddenly if we found that one, we'll say sb dot append, and we'll append what, our sb, and we'll add say 1 here. And if not, else, then what we'll do, sb dot append 0. Got it? This part is done. Then if that is not the case, if both cases are done, which one is will pass? Always divide carry by 2. Always divide carry by 2, so that you will get our carry, final carry. And then if carry is now have if carry is, now what we have, carry is equal to 1, suppose what we will do, we will append our sb dot append again with 1. Not we should pass single quote actually. Yes, pass characters. We are talking about characters always, we should not pass string. Okay, like this. So this is done. Now carries, we have checked all the carry. Similarly, at that time we'll do sb dot reverse. Okay, so whatever the data we have in the sb, we will reverse it. Okay, and then finally we will return you can say sb dot to string. We have to return in into string. So from sb string buffer to string we have to do, and then we will do. So I think you understood it. Let's understand. As I told you, right, the example we have already seen, right, initial that first approach, right. What we used to do, we used to take the string into integer, then we'll add, then we used to return. Similarly, what we will do, we'll take n1 and n2 length, and we'll check the length, which one is length is big, if n1 and n2 is there. So we'll do the reverse. We'll not do anything, we'll reverse binary will do, and we'll check the maximum length n1 and n2, right. So we'll check these variables, just for we'll check from the maximum, which one is maximum string in a or b. From that the last index we'll choose, and we'll come to the first index, and we'll check in a will check all the character of a, and we'll do carry. Again we'll check in the b, and we'll check the carry. We'll increment our carry, actually we will update. We'll do the modulus, you can say we'll do mod of, you can say 2, and we'll check if a equal to what 1. If this is 1, then we will append our sb as 1, and if not, we will append 0. Finally we'll coming to there, we will append our carry. We'll divide the carry, and we'll check if carry has 1, right. Then what we will do, we'll append the 1 in the sp, and then we will reverse our string buffer, so that we will return our value into. Now we will converting string buffer to a string as object, string buffer object to a string. Let me compile, let me submit this one. This is working, yeah, good. Now we can take another approach in the second part of this video, so stay tuned, in which we will see the bit manipulation approach, right. So in this part of video, what we have understand that that if we'll talk about the complexity, okay, let me go to here, we'll see the complexity. Let's suppose complexity, okay. So complexity, we have what, tc we have, if we'll say we have a and b, right. So let's suppose if a have n1 length and b have what, n2 length we have taken, right. Two length of the input we have, a and b, right, and n1 n2 we can say. So max will say will take the maximum between a and n1 and n2. Which one will come, that will be our time complexity, right. So always think about this one. Now to the space complexity, the answer will remain same, okay. If you consider a as m and n is n, right. So you can say m and n will take the max, and this is our complexity, okay. So understand, as for our example, n1 n2, and we represent the time complexity, space complexity. In the second part of this video, what we will do, we'll take a bit manipulation, right, bit manipulation. So what is bit manipulation, okay. So think about the you can say intuition, right. So the input is more adapted to push toward approach 1, right. But there is a popular you can say Facebook variation of this problem, when interviewer provides you two numbers and ask to sum them up without using addition approach, right? You think you have understood that question, right? So we used to see the popular Facebook question, right? Like the interview has given two number A and B, and you have to do the sum. You have to do sum, and you don't have to use the addition approach. Plus approach you don't have to do without the plus operation, and we have to return the sum of A and B, right? So this question we used to do, right? So what we can say, these things we only can do by bit manipulation, right? Without bit manipulation you cannot start this one, right? So to understand, let's understand one example and we'll try to implement. So if A have suppose A have we have 1 1 1 and 1, okay, like this. And consider if B have you can say 0 0 1 0. We have already seen these things, but let's understand. So what we will do, we'll take one answer without carry. Answer without carry, let's suppose what we will do, A like this, right? We used to do, we'll do the you can say JOR operation we'll use. So if you understand the JOR, let's suppose we'll do the JOR as a key, and because it's a sum of two binary, right, without taking any carry into this one, right? So we'll do the operation like this, okay? So what will happen if you'll do the JOR of this one, right? So what will come, the first what we have 1 0, here is 1 and here is what, 0. So what will come, if 1 and 0 is there, it will come 1, correct? Next what we have, 1 and 1 we have, okay? So 1 1 become what, 0, correct? Now we have 0 and 1, what will come, it will come what, 1 and 0 1, and if we have 1 and 0 it will come 1. So if we'll represent this one into this, we can say this is our answer, right? 1 1 and 1 1, okay, like this, right? So answer without carry, if we'll talk about, this will become like this, 1 1 0 1. So to find the current carry is quite easy, as well as its AND of two number will take, it shift one bit to the left, right? What I'm trying to say, you understand this one, right? So let's suppose again, if we have A equal to what, we have given 1 1 1 1, okay, and B have we have given let's suppose 0 0 1 0, okay. So if we'll say answer without carry, will take A like this one, right? Sure. Then what will happen, we are taking what, 1 0 is 1 1 1 is 0, we are taking 1 0 is 1 1 1 is 1, we are representing this one. But if we'll do carry, right, we have this carry, and we'll say A or B will take, and will take left shift of 1, right? So we'll get the carry, right? And in which what we will do, so 1 0 is what, will, if we'll take the carry, 1 0 is coming 1, so here carry if we'll take, what is carry we have, carry is 0 we have. If we'll taking 1 1, right, and what we are taking 1 1 is 0, so what is carry we have, 0. Second time is, it is coming what, we have 1 0, now carry is coming what, 1. Next time what will come, 1 0, carry already we have 1, right? So now next time if it will come one more, then it will, what will become, 0, correct? And for the final, what we have the carry, we don't have any carry now, right? So it will become sorry, it will become 0 only, okay? So this will become our carry. So if we represent this one in like this one, right, it will become like this, okay? I think you understood, right? And this is our B we have, and this is our 1 we have, A. Let me change the color. So what we are doing, we have 1 0, 1 0 is 1. We have what? 1 1 is 1 1 is 0. We have 1 1, it become what? 1 1 0 1 0 become what? 1, right? 1 0 is 1. And carry, if we'll talk about what is coming, 1 0 coming 1, no carry. We have 1 1, no carry. We have 1 0, 1 carry, 1 1, no carry, because previously we have 1, now we have added one more, and then 0. Like this we are getting. Now the problem is reduced, right? And we have to find the sum answer without carrying and carry, right? So it's the same problem, two sum, two number, right? So we should solve it in a loop with we can say conditional statement, with a conditional statement while carry is not equal to 0, right? Well, carry is not equal to 0, then what we will do? So what approach we should do? First we will convert a and b into integers, right? Let's suppose after conversion it will become x and it will become y, right? So we have what? X and y. Now what we will do, x will be used to keep an answer, right? And y will be become y will be used for carry. Okay, so while carry is non-zero, let's suppose I'm talking about if y not equal to what? 0, this one. If y not equal to 0, right, then what we will do? Carry answer, current answer without carry is what? Jor. Without carry is, you can say answer without carry is jor, that we have already seen, right? We'll take answer as a you can say x of y, you can say, right? What I'm talking about. So this will go to our answer, and y will go to you can say carry, right? So first we'll check, we'll check this condition. If this y not equal to 0, right? Y not equal to 0, current answer is, we'll check the answer, current answer is without carry. If no carry, we'll say jor is like this. And if we'll say current carry is left shifted and of x and y, so it will become what? Carry will become you can say x and y, and left shift of one left shift will take. So then our job is done. Then what we will do? We'll next loop will say x is our answer and y is our carry. So we will prepare this loop till this thing happen. Okay, so now finally once this is done, we will return our answer, that is our carry. This answer we will return as our carry. So better we'll go to the code and we'll implement this one. Okay, let's go to here. So what I will do, I will remove from here to here. Okay, yeah. So what we should do, we should take two things. The first we have to take we have the function, this binary, we have a and b, so we'll convert into big integer, right? Let's suppose I am taking in big integer, and that is what we will take two variable. X is nothing but it will come from what? Big integer, and it will come from what? A. We'll say this is binary. Similarly we'll take what? We'll take a, and this is our b. Okay, so one will take answer, this is x and this is y. Now both are converted. Now we'll check this is 0 or not, right? We should take one more. We'll say this is our is 0. If this position contains what? Let's suppose 0 and come to here. Okay, 3 things we have taken, and one more we should take, that is answer and carry we should take. Let me do similarly. I'll take 2 things and we have to make the loop, right? First is our answer. Okay, short take will short talk, and this is our will take one carry. So one place will take in here only, and this is our carry. Answer and carry we have taken. X, Y we have already converted, and we have this, right? So let's see this one. Now what we should do, now we'll make a loop and we'll see if while y that we have converted will compare. Is a compare function, right? It should compare actually. Compare to, there is we have find if it is equal to 0, right? If not equal to 0, if it is not equal to 0, then means what? We have got our answer, right? So we will prepare our answer. Answer is nothing but our, we have to take x, and there is a let's suppose JOR is there or not. Yeah, we have JOR, and JOR will pass our y, XOR. Okay, whatever you say pronunciation. Okay, I'm used to say in the college JOR JOR only. Then we'll take carry, and we'll say x dot there is a x, yeah you can say x dot we'll do and a and d. Yeah, we have and also. So we'll pass y, and then we'll check the shift, is the left shift is there or not. Left shift should be there. Why it is not coming? Shift, yeah, we have. So what we will do, say 1. Now what we'll do, we have x equal to our x dot and y we have did, and then we will shift. Okay, let's try. Then we'll say we will update our answer as x is our answer and y is our carry, and this loop will continue till we have done our we'll got our answer. Then we will return x, will convert into x is our answer. So we'll say x dot to a string, big integer to string, and we'll say move to 2. Let me try this one. Big integer is not here. Okay, so we should let import java dot math dot big integer. Yeah, one 110 it is coming. Okay, what was first we have taken? We have taken one big integer a and b. We have taken, oh sorry, see, due to the copy paste this issue will come. I should write that time. Now submit this one. Okay, so this is working fine. Now what we will do, if we'll talk about the complexity, right? So if you say we have n and m, right? Or you can say previously we'll taken length of a and length of b is n1 and n2. So similarly what will happen, the complexity, if we'll talk about the complexity here, right? So I'll say n1 is for length of a and n2 is length of b. So this is our time complexity because we have the input of this one. We are not doing anything extra, right? But while this is our time complexity, you can say TC, time complexity. But you are talking about the space complexity. Okay, what will happen? We have to find the maximum of that, right? So we'll say max, and similarly we'll say n1 comma n2. Okay, while because see the space will take like that only, because we are doing what we're trying to go to the max of which one is max, till that we will go, and it will do the carry things, right? So this will take the space as a max of n1 and n2. So thank you guys, thank you so much for watching this video. If you like these two approaches and one navy approach, right, so please hit comment and subscribe this channel for the future videos. And this video, this question is very important for the FAANG preparation, so make sure you have the right approach, and you can say you have the hands-on on these questions, right? If you understand what will I will recommend you to do some hands-on using your you can go through this video first, right, and then we'll complete. Okay, again, do practice more. Thank you so much.